Okay, hello everyone. Welcome back. So today is part 11 for building AI improviser from scratch. It's been a little bit since I last posted a video. Since last weekend, I was hosting an academic conference. Actually, I was one of the organizers, and so that was very busy. And so today I'm finally back onto building this and want to update with a video. So we're at the stage now where we're refining some of the communication within the patch, but also thinking about building out lots of different behaviors. And then after that, we'll finesse how we move between behaviors and how we use these behaviors. I have a document here that I've been working on, just jotting down ideas for how to organize the behaviors and maybe the order that I build them, and then some other sort of bonus things that I'd like to include in the patch. So what I've already done and what I'm going to show today are some rhythmic behaviors that I've designed. So these follow upon, I believe it's like, maybe it was the third or fourth or fifth video in the series. Anyway, it's titled so that you'll be able to find it easily. But there's one where we built out all this, all these rhythmic devices, mostly using Gen. And so adapting those and combining those with the BPM detection, pulse detection into rhythmic behavior. So that's what I've already done. So I have a whole bunch here that I'm just going to go through. Or we're not going to build together. I'm just going to show you what I've done, and then you can use these or build other behaviors based on these ideas. I'd love to see folks doing that. Before then, I did update a little bit of these objects. I added a bit more communication, most notably the label count. So basically, if you change the number of labels, it will give that it can send that information throughout the patch, which will be important for behaviors that use labels. So if a behavior is supposed to call upon 15 different labels, it's not going to work if there are only, say, 10 behaviors. Or if it's only using 4 behaviors, it's not really using the full gamut of the audio corpus otherwise. So I'm making my behaviors adjust to the number of labels within the analyses. The other update, this subpatcher. So I have a Markov chain being built about that describes how the patch moves between labels. So this is going to come in handy. And actually, maybe in this video, I'll expand one of the behaviors I've made to use that Markov chain. And then also in the same place, there is now this, which I think I began building in the last video, but basically it sorts out the slices or grains, depending on if it's a slice or a grain analysis, and puts it in an urn. And so you can call back randomly within the label types. And finally, now it will show the label number as you call back things. Okay, so I've already loaded in and analyzed the audio corpus. So this is the audio corpus is made of a couple short improvisations by Andrew Kozar, who is a great trumpet player based in Boston and New York. And I'm working on a piece for his duo, the Bjorn Kozar duo. And for that piece, there's a lot of electronics that uses techniques similar to this, but so in any case, those are the samples you hear. They're all trumpet samples from improvisations. Right, great. So let's do it. Let's look through our behaviors. So I packed up the behavior we made in the last video so that it can easily be turned on and off from here. Ba, ba. a couple of things for behaviors that I've planned. Basic distinctions between what the behavior is. So does the behavior lead the music, or is it following what it hears? And of course, there's sort of a gradient between those two. Is it imitating what it hears? Is it contrasting what it hears? All these different things. So even, rhythmic here, but then of course, even within a rhythmic behavior, we could think about things like consonant versus dissonant, noisy versus pitch, high versus low, accompaniment versus leading, all these things. So let's go through the behaviors I've made so far. So this one is just a basic metro, so it'll give a pulse, and I've named it rhythmic leading basic metro slow variation. So this is sort of a slower range of tempo. So anywhere between 120 and I guess it would be 159 beats per minute. And it will go randomly between labels, either chroma labels or chroma slice labels, MFCC slice labels, or melband slice labels, and based on this gate here. So when it's turned on, it chooses one of those three paths, and then it will just play with that BPM evenly one of these labels. And then there is a 1 in 20 chance, so a 5% chance that on every attack, it switches what label it plays. Yeah. And again, here is the label count that I was mentioning earlier. So we know the maximum number of labels, or like the highest number of label that it should be calling upon. And because labels start at 1, not 0, I have the +1 here. And then here is for the panning. So it can move up to 5% in either direction in the stereo field with each attack. So this is just to sort of have things have a little bit of movement, but not be totally random in where they appear in the stereo field. So let's, and so the same thing with the medium variation. It's just a little bit faster. So the random is 150 and is at least 60 beats per minute. And then finally the fast variation, where it's could be anywhere between 120 and 269. Okay, so let's listen to those. And this is totally doesn't react to the live input whatsoever. So this is why it's at the extreme end of leading. Medium variation, fast variation. But already, so this sort of creates a texture at this speed. If I turn on my more dynamic matching behavior from last day, I could see how it's already sort of could be built up into an interesting texture. Anyway, I don't know. Is improvising a little bit with it. Sort of fills out the sound once you have a couple of these on. Okay, second one. So again, we're using it's very similar to the three that I already showed, except for this one, the only difference is that it's using the BPM detection. So here it's detected like a 233 BPM as I'm speaking. Bum, 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 bum. Right, so again, very basic, and there's using the labels again. For this one, it's the same idea. It's getting the BPM into a metro, so giving that even pulse. But here we have it randomized whether it's played forward or backwards, and we also have it following the gain somewhat. So if I'm louder, it's louder. If I'm quieter, it's quieter. And it's also doing live matching. So it's going to try to match using the mel bands what it hears in real time. So here it's leading a little bit because it's imposing the BPM that it detects, but it's kind of following in lots of different ways as well. Bum 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 ba. Ba. So you can hear how it's timbrally switching with me using the mel bands. And here it's the same thing but with chroma. So ba ba chip. So yeah, I like chroma. it's kind of cool when you have like noisy stuff like that as well. It still kind of has pitch content in it that connects. All right, the next one is a pretty simple implementation of meter. I think I could probably make lots of variations on this one, but for now, it when it's turned on, it'll create a random metrical division between 1 and 12. So you could think of it as anywhere between 1/4 and 12/4 bars. And then I have, this could be more, sorry, I want that as well. This could be more dynamic. Right now it's just sort of a set of weights, probability weights, up to 12, which are then given to the subdiv object. And then this number, as it counts through, is, so you see how sometimes it gets a trigger, sometimes it doesn't. And then this number is being sent to label triggers. So it creates a pattern through the labels. So let's listen to, and this is entirely unreactive. With the exception of the BPM detection, it is just purely leading the sound. Let's try another one. So you see how it kind of creates a pattern between it. Now, depending on what your corpus is, that can sound really different. This corpus, it's kind of a mixture between rhythmic attacks and textural stuff. So yeah, it would sound very different with like all percussion samples, for example, or all kind of droney soft attacks. You get very different results. All right, the next one is ratchet rhythms. So again, this is very much a leading one. So let's turn it on, see what it sounds like. So something like that, I think, could sound really interesting, especially with, very fast, strong attacks. This is a ratchet that is following BPM, but is otherwise very similar. Dum bum 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 bum. Okay. The next two are chaotic. They use a Lorenz attractor. This DT number, the way I've implemented it, it kind of corresponds to just how generally active the attacks are through edge detection from the, DT, DY, and DZ, XY and Z, DX, DY, and DZ signals that come out. And then this is going to, each one is going to a different label. So again, this one is very much leading, not following. And this one, more than the others, just kind of creates a chaotic texture. But because of the mixture of recurring labels, it has a kind of consistency to it, which I enjoy. And this is one that is using grains rather than onsets. So it's a little bit kind of softer, more drone-like and textural. So So something like that. Again, the corpus really defines what the music will sound like. So this is all with the trumpet improvisations, but with different corpuses, the sound's going to be completely different. And this one, I think you create some really interesting, a variation on this with chroma, for example. You can create some really interesting sort of harmonic devices, and I'll expand that out. Another one that I will add, sorry, not in there, is this Euclidean rhythm, which will be very easy to implement. In fact, why don't we go ahead and build one, and then you can sort of see my my process. So let's build it off of, let's see, I want one where it also has random directions. Let's build it off of this. So let's call it rhythmic Euclidean, hope I'm spelling that right. And then let's use chroma slices. And we'll use labels. Okay, great. So we're gonna get rid of all this. And let's bring in the Euclidean rhythms here. Oops, hold on. Bring that up here. Now, we don't necessarily need to see all of this. It's nice. I mean, those ones are kind of nice to see. What is that coming from? That's coming from down there. All right, let's just leave it. It doesn't take up much processing power, and it looks cool. So right now it's at 120, but let's get BPM and bring it in there. Great. The BPM tends to be on the faster side. Let's divide it by 2 so that we can have further subdivisions without it getting too chaotic. Again, it would be very different with entirely very sort of short rhythmic samples in the corpus, but these are sort of longer samples. I don't want to get too messy. All right, so we already have, the measure, 16th, and quarter notes. We'll use chroma slices. Chroma slices there. Chroma slices pan. Chroma slices direction. And we're going to use that 3 times. 1, 2, 3. Now we're going to have to get the label count, we're going to have to send that out again here because of course it's not sent when I create these objects, it's sent when it does the analysis. It'll select the label once randomly when it's turned on. So we got a random combination of 3 different chroma labels. We could use the urn to do that as well and spray them out so that we don't get repeats, but I don't mind repeats actually for this. And then we'll just want a gate for each of these so we can turn it on and off. So we'll do a gate for this, and a gate for this. And we'll want to use the toggle that's turning on and off the whole behavior to turn on and off the gate. And then we will want the quarter notes, 16th notes, and the measure. And then this will trigger the sample, move the pan, and decide if it's being played forward or reverse. Same with this one, and same with this one. So let's turn it on and see if it works. Oh wait, I want to actually get randomized things there. Great. Now let's turn it on, see if it works. Back to behaviors. Cool. Well, it all got a 1. Hold on, let's try that again. There might be some mistake there. Oh, Mel slices label count. What I want is Chroma slices label count. I'm just gonna let that go. Kind of like the quirky sound it's making. Okay, so let's turn that off. Gonna have to do this again so it gets number 19 into the random object. And behaviors and on. There we go. Cool. So again, there's a lot of variations on that we should and will make, but for now you get the idea. All right, the last things I want to show are just these simple gestures I made. So using the bouncing ball rhythms. So this is just a curve, taking a snapshot from a curve to create the illusion of a bouncing ball rhythm. And so there's short ones. That's very short. There you go. There we go. It wasn't that short after all. Oh, it can be up to 8 seconds, so. One that's longer, so this one can be up to 13 seconds. I might make this one a little shorter. Up to 6 seconds long. And then the same gesture in reverse, where you have slowing rather than speeding up. Great. So that's a bunch of rhythm behaviors made for today. In the next video, we will keep building behaviors. I'll have a whole other suite of behaviors. We'll just keep expanding behaviors until we have an absolute pile of them. And then we'll figure out how to make them useful in combination with one another and more reactive to the incoming sound. Okay, so with that, I think I'm done for today. Thank you.